And again, everyone, welcome to today's webinar, Serverless Big Data Analytics using Amazon Athena and Amazon Quicksight. We have two presenters we're excited to introduce to you today. Our presenters' names are Greg Kurala and Ben Snively. Greg is a Senior Manager of Business Development at AWS, and Ben is a Senior Solutions Architect with AWS. Today with us, we're also excited to have a great team of moderators who will be able to engage with you throughout the presentation by answering questions that you may have. On that team, we have Satish and Quinton. Again, they're ready to answer any questions you have, so please feel free to send them over at any time. Now, Greg, welcome. The floor is now yours.
Great, thanks, and welcome everyone. So I'm Greg Kurala, so I lead our business development team for analytics, and we're going to be walking through some definitions around big data and analytics and how it relates to serverless environments. But before we get into it, I just think it's important to think about what's the problem set or what's the question customers often comes to us around analytics. And this is the idea that data is available in ever increasing volume, variety, velocity, but our ability to analyze that data is constrained by the tool sets or architectures to actually explore that data. And so if you look at some independent third-party studies, they would say most data generated today is actually unavailable for analysis, particularly when you think about news sources like social media that increase kind of those 3 V's or volume, variety, velocity of data. So I think one of the big goals of serverless analytics is how do we start gaining insight into this ever increasing richness of data sets that are being used. So of course, the problem or the solution potentially to this dark data becomes serverless architectures. And just to provide a quick overview of what we refer to by serverless, it's important to kind of think about where the cloud architectures have actually evolved. And so initially it was all about, hey, let's virtualize our environments. This virtualization can provide flexibility to really unlock that dark data. And then over time, as virtualization matured, we started talking more about managed services. This is thinking about like a database as an endpoint or the ability to have third-party potentially even managing that infrastructure. But there was tremendous amount of work and sort of transformations of data, which has then evolved into what we can now call serverless analytics. And this means we want to remove the barrier between an analyst having a question and the actual answer or insight, and making the infrastructure that's actually providing the resources to answer those questions appear seamless to that analyst or set of users that have questions. And so some of the characteristics of serverless becomes, of course, as its name implies, there's no servers to provision or manage. Of course, we all know that we live in a physical world, and so there certainly are servers behind the scenes. But the idea is that you, as an analyst or as a business person or just someone that has a question, you don't have to think about the notion of, do I need one server, 5, 10, and I simply want to be able to scale without limits as well. So maybe I start off by providing analytics to 10 users, that grows to 100, to 1,000. And particularly when we get to these kind of questions at scale is where limitations of traditional physical environments really come to light the most. And so can we provide a serverless environment or seamless environment where I'm not only alleviated of kind of the management and infrastructure side, but also able to grow as my business or analytic questions grow as well. And then important to that, particularly when we think about scale, is how am I looking at things from a cost perspective? So if I'm only answering or asking questions periodically throughout the day or the month, can I eliminate that idle time from my cost infrastructure? And so oftentimes you might think about scaling for peak usage, which of course means you have to pay the most upfront, even though it's not being used. So one example might be if I have a seasonal business, so it might be holiday time, and so people are going to be asking more questions, but can I simply grow into that seasonality and then, and more importantly, retract back from a cost and infrastructure perspective? So only pay for the resources when they're being utilized and have virtually unlimited scale on the top end. And then, given the critical nature that analytics plays in most businesses, can we think about just availability and fault tolerance just being a native part of this service as well? So not only am I not managing, the infrastructure behind it, but I'm not managing the critical parts like high availability, disaster recovery. And those are all just inherited components of the architecture to be able to provide that insight and really unlock that dark data. So we'll be talking about a couple of Amazon Web Services that can deliver on this. And the first is going to be the idea of Amazon Athena. And of course, the first point is that Athena is itself serverless. This means that there's no infrastructure or administration. You don't have to think about, do I need a small, medium, or large configuration, or the number of compute cores, or I/O. You simply just have a question you can express through SQL. You have data sets that sit on S3, and you can just immediately start asking questions of the data through SQL. And we handle all of the important tasks such as provisioning and infrastructure and upgrades. So there's literally zero time to spin up. So whether you ask one question a day, 10 questions, 100, 1,000, you can simply start exploring your data as it sits on S3. The next point is that Athena is actually super easy to use. So if you prefer kind of a console or SQL environment, if you're more sort of adept in terms of just writing your own SQL, you can log into the Amazon Web Services console, write your SQL directly there, and get a result set back. And this works equally well for defining the data set, so creating the table structures over my data on S3, or actually asking questions from SQL perspective directly through the console, and start querying it. So again, we want to remove the barriers to adoption. And this is equally true whether I have 5, 10, 100, 1,000 people asking these questions. It becomes super easy to start exploring the data. And I will call out that Amazon Athena is also available through JDBC. So we'll be highlighting how I can sort of move beyond just writing SQL code to actually visualizing it through Amazon Quicksight, our business intelligence tool, or any other visualization tool that's available through JDBC connection. The next point, of course, as we talked about some of the characteristics of serverless, is that Athena itself is highly available. So you simply connect to the endpoint either through the console or through JDBC, and you then inherit not only this vast compute pool that we have behind the scenes to actually process your queries, but actually the fact that your data is stored on Amazon S3. And this is a super important part where we think about open data formats on S3. So we don't want to transform or lock your data into proprietary structures that are only accessible through a tool like a SQL query tool, but simply say, I've got an open data format on S3, and we'll talk a little bit more about what some of those are, and then inherit all of the availability and durability that S3 delivers to actually store the data itself. And importantly, that we have this idea of storing the data is that your data is actually stored on S3. So we're not magically or secretly transforming your data into some proprietary format that's only available for Athena to query. But the fact is that we maintain the open format, whether it's a text file, a JSON file, web logs. If you're familiar with some of the Apache file formats like Parquet and ORC that are optimized for query performance, you can natively use these file formats and then have analysts issue SQL queries against it. But then actually, another interesting part is if you have any other service, whether it's Amazon EMR or any other Hadoop component or software that understands a Hive metastore, that understands these data file formats, can actually query or programmatically access that same exact data. So having multiple teams, whether they're using SQL or programmatic access to the same data without having to copy and add expense and overhead of managing multiple copies, is really some of the highlights of the fact that open file formats on S3 brings. And of course, this idea that not only can I have static files, but be able to integrate streaming sources. So for instance, if you're using Amazon Kinesis Firehose to land data in S3, the fact now that you can immediately start querying that data through Firehose into S3 is another important advantage of being able to query S3 directly. And then the next point would be this idea of using ANSI SQL. So it's sort of interesting, from my perspective, attending a number of conferences and seminars, particularly around the Apache Hadoop community, that there's a big trend in terms of just enabling SQL access through Hadoop stack. Of course, that then requires you to set up and manage your infrastructure. So from one sense, the idea that Athena provides a serverless environment to allow full SQL access or ANSI SQL access allows analysts and customers that understand the SQL language to immediately start taking advantage of many of the Apache file formats on S3 and removing that barrier, or essentially closing that dark data gap, such that we can start getting result sets back from these file formats on S3. And the fact that there are not just simple queries, but actually being able to do complex and nested queries or complex data types really doesn't limit the type of questions that analysts can provide through that SQL interface. And then from a pricing perspective, we talked about some of the attributes of serverless environments such that you're not paying for idle time, which can be a huge cost benefit as well. But then thinking about how do I actually leverage this vast compute pool in terms of executing my queries? So whether, behind the scenes, whether your query requires 1 CPU core, 10, 100, 1,000, shouldn't necessarily inhibit the way the analysts interact with the data. So the fact that we have a very simple pricing, which essentially looks at the amount of data you scan on S3. And I'll kind of call out why scanned is sort of an important attribute, such that the more I compress my data, the more I partition my data using formats like Parquet, I can dramatically reduce my cost of querying and interacting with the data. Again, regardless of the number of infrastructure components in terms of compute power or memory behind the scenes that's being utilized to process the queries themselves. So the first is that when I define the table structure on S3, so we use Hive DDL, which is essentially a very common way to define table-like structures on top of open formats like Parquet and CSV files. So we don't charge at all for the data definition or the Hive DDL components, and so you can create as many different views on top of this data. We don't, of course, we don't change the file formats themselves. We're just providing a table-like structure over the data, and those Hive DDL or data definition languages there's no charge. As well as if any case I have like an error in my SQL or I just got incorrect results, we don't charge for failed queries either. So let's just assume that we've defined our table structures using Hive data definition language. I have my open file formats on S3, and now I start querying it. Well, here's just a simple example where if I had a log file stored as text, and it was 1 terabyte, and I did essentially a select star against that, I would get, the cost here would be $5, right? Or for a specific query shown on the right, you can see that would cost about, $5.75 in order to query that 1 terabyte of data. If I just simply think about this data in a different way and say, okay, I've got the same data, but now I've converted that into a Parquet file, not only do I dramatically reduce the size on S3, so now I'm down to 130 gigabytes for the same exact data, but now my price is just a fraction of the previous view of the raw file as CSVs. And guess what? My performance of the query is dramatically faster as well, because the Parquet format is not only optimized for storage in terms of reducing the size, but it's a columnar format, and so I can take advantage of the query effectiveness by looking at Parquet. And of course, there are many other formats such as ORC and Avro and JSON and on down the list, but we just wanted to use one example of Parquet to kind of show how not only from performance perspective, but also price perspective, formats like Parquet and others can really help drive the cost down. And this is important not only from an Amazon Athena perspective, but also comparing to other options you might see where the data processed is actually the metric. And so we think this is an important distinction that customers have really gravitated to and have really driven a lot of the adoption of Athena, is that the more you compress your data, the more you partition your data, you can drive dramatically lower costs. And so once I've thought about the idea of I have an ability to write SQL statements directly against S3 in this serverless environment to start unlocking that dark data, we now move to the next area to say, okay, not all of my analysts understand the SQL language directly. So these are, folks that more just want to explore the data. They need a visual environment to drag and drop. So can we provide a solution set for this type of user where we're not programmatically writing SQL directly? And of course, this fits directly with Amazon Quicksight, our business intelligence service that allows business users or non-technical users to easily explore all of their data sets, not just data sets on AWS, but wherever those data sets reside. And we think that combining Athena and Quicksight is a great solution for analysts that need to unlock this dark data and then visualize it in a drag and drop environment. And so who is Quicksight really for? Well, of course, it's for anyone who wants to explore data visually. This can be, business users, data consumers, data professionals. And it's really the perfect solution in terms of delivering dashboards and publish reporting out to my end users who want to visually consume that data. And if you think about some of the concepts, and we'll get into, when we get into the demonstration, this will make a little bit more sense. But, of course, underlying Quicksight, we have all of our data sources. And so today we're focusing on Athena as one of those data sources. But, of course, it can be any database under any relational database. It could be Amazon Redshift, AWS's solution for data warehousing. Or it can even, interestingly, be a flat file on S3. And we'll talk a little bit about why you might want to just visualize these files directly from S3 as well. But the idea is I have this wide variety of data sources. And then I want to think about, well, how do analysts actually interact with this data? They might not understand, the tables or the schemas, the technical names we have in the database themselves. And so can we abstract those technical definitions from the business user? And we do that through the concept called data sets. And so a data set is just saying, I've got a subject area, like let's say retail data, that might correspond to any number of tables in my Redshift database, for instance, or files on S3 that we're exposing through Amazon Athena. But the business user understands retail data, right? And all the metrics and dimensions that they essentially want to explore the data through. And so the data sets essentially provide an abstraction between the complexity of the data sources and the way the business user or analyst might want to then explore the data. And of course, once we have the data sets defined, any kind of joins defined, renaming, the analyst can come in and see their data sets and then start creating analysis, which essentially are the visualizations or reports, and then combine those analyses or reports into dashboards or storyboards that other users can essentially consume and visualize as well. And so we'll go through a demonstration of how this is built out, but understanding how I go from maybe the raw data or the data sources all the way to the dashboards and abstracting the complexity is one of the key value propositions that Quicksight brings. And of course, Quicksight itself as a managed service means it inherits many of the characteristics of serverless environments, such that you don't manage the infrastructure. You simply tell us the number of users that need to get access to it. And of course, it's deeply integrated and has native connectivity to Amazon Web Services data sources, such as S3, Redshift, Aurora, and Athena, of course. And what this really means is that, one of the downfalls or challenges in the past of business intelligence tools is that we spend a lot of time configuring ODBC or JDBC sources. Do I have the right driver or the right version of the driver? And so with Quicksight, we just simply can point to a data set and start working with it. Of course, you need to provide the correct credentials to log into the system, but as part of the Quicksight service itself includes all the connectivity and deep integrations back into AWS data sources. And then to accelerate performance, we have a component of Quicksight called Spice, which is essentially the super fast parallel in-memory calculation engine. So in traditional business intelligence tools, the experience the end user sees is directly related to how efficiently I've organized my data structures. And oftentimes in traditional BI tools, those data structures must be a relational database in order to issue queries back to them. So the first point is that, can we abstract not only the definitions and the metrics such that business users can interact with it, but then can we cache the most frequently used data or the data set that the analyst is most interested in to an in-memory data source seamlessly to the user, such that now they're not inhibited by the performance of the underlying database, but can simply explore and interact with the data as their thought process proceeds. And so being able to have these result sets not only available for analysis, but actually cached in this in-memory layer through the Spice engine becomes a big driver for customer interest in Quicksight as well. And it's an additional feature that comes included with Quicksight is this caching through this in-memory data source. And it's what this really leads to is this combination of the visualizations, the abstraction of the complexity, as well as the caching layer becomes a super fast and easy way for end users, analysts to essentially explore the data visually and not be constrained by the definitions or sources of data that are available in traditional tools. And then, as we all know, in today's environment, it's not just about interacting with data through a traditional web browser on a desktop or laptop, but being able to look at not only reports or analysis, dashboards and storyboards, but then consuming them in an ever increasingly mobile environment. So whether I'm on a tablet or a phone device, can we essentially be able to look at the same information or the same reports on the device that makes most sense for my business? So if I'm a mobile part of a mobile sales force, perhaps I want to be able to consume my latest, reporting dashboards through my phone or tablet device, and kind of having this ability through Quicksight becomes a popular feature as well. And then, one of the things I would to call out is that, we increasingly and quickly iterate on adding new features into Quicksight. And so it's been, was first generally available back in November of 2016. And since then, we've added, additional capabilities such as scheduled refreshing. We've launched in additional regions such as Ohio. We've added support for new data sources such as CloudTrail logs. We added support for Presto and Spark as a data source. And definitely encourage you to stay tuned as we continue to iterate quickly and adding to the richness of data sources and visualizations that are available for business users to explore their data, with the end goal being, how do I close the gap of the dark data? And so dark, the data doesn't just exist in one format or one system, but being able to have a seamless way to explore the data wherever it resides, and something that our team is super focused on continuing to deliver innovation around. And just wanted to kind of, before we get into the demo, just kind of tie together what we see to be a simple pipeline of maybe traditional business intelligence tools, particularly as it relates to analytic tool sets as it relates to AWS. And of course, we start off with our data sources. These could be transactional systems, either in AWS or on-premise. These transactional systems oftentimes, land data, the raw data into S3. We might transform the data using Amazon EMR or other ETL tools, put this prepared data set back into S3, and then load it into a data warehouse like Redshift, and then of course visualize it. And this is, still, super valuable to many customers to be able to kind of follow this pipeline. But where things like Athena come into play is, now imagine I have a set of users that want to discover the data in this raw format. This could be sort of like a compliance type question or infrequent question where they need to get access back to the base or raw information. So being able to simply, spin up Athena or go to the Athena console and just start querying the data through SQL becomes a super compelling use case for many, many users. And then the next one is to say, okay, even in the case where I want to now explore some of the more prepared data sets, I can use Athena to query that directly, or I can combine it with my other enterprise information in a more traditional data warehousing perspective and continue to query it through Redshift. But the beauty is that with Quicksight is that from the visual perspective or from the business intelligence perspective, the consumer doesn't necessarily have to care about where the data is stored. They can visualize all these result sets into a single set of tools to do exploratory analysis. And it's not necessarily a question of when do I use one or the other, but how can these tools together deliver the most value for your use case, such that our analytics teams or essentially people that have questions about data can choose the right tool for the right scenario and not be constrained by the fact that, hey, we purchased a certain technology stack and therefore all questions have to go through that single stack. And so kind of having this flexible analysis of data warehousing through Redshift or exploratory analysis through Athena, and then tying that together in a single visual interface through Quicksight oftentimes becomes a compelling business proposition to close that dark data gap and to really provide more value out of all of our data and not just curated sets of data. So having said that and giving a bit of an overview of Athena and Quicksight, the next part we wanted to turn over to Ben and actually show a demonstration of the product sets together.
Okay, thank you. Thanks, Greg. So the way we're going to start demoing today is we're going to actually act as a role as a business analyst or somebody who wants to start using a BI tool and start analyzing some data. The data set we're going to be using in the demonstration today is this New York City transportation data. The way this is split up is there's about 8 years of data, and each data set is split up into 3 different high-level categories. We have yellow data, green data, and for-hire vehicles. And as a business analyst, I want to start analyzing this data. So I'm going to go into Quicksight here. And within Quicksight, we have various analyses that have already been done, already displayed at the bottom. These analyses could be shared within your organization. You could create them. You could create dashboards from them. So it's a really good way of capturing a lot of visualizations within one display here. So we're going to go inside an existing analyses. And what you'll notice on the left-hand side here is various dimensional data, along with measurement data. And what's happening here is there's multiple visualizations shown here, and this interface allows me to select various attributes to be displayed here. So right now I'm in analysis mode, so it's very easy for me to go in and modify the look and feel of this. So I could easily go in here, change, for example, the way numbers are displayed. Let's say I only care about whole numbers, and I could do that on this chart, and all the tooltips nicely show whole numbers now. This data set also is showing multiple visualizations. So this first one is across all the 3 types of taxi data. It allows me to see various fare amounts based on the rate code. This is also a KPI. This is week over week how much revenue is changing. So I could very easily select this. I see the KPI chart down here, and you can see over time we're analyzing the total amount of fares summed up per week. And then we have a couple scatter plots, and these are really good at showing various anomalies. For example, this one data point actually had a fare of $200 and it went less than a mile. So within this dashboard, it's very, very easy to start dragging and dropping these features, being able to drill into various features. So I could select one of these and drill into it all through this interface. Let me start fresh though and create a new analysis. So we're going to go up here. We're going to create a new analysis. And this lets me select this data set. So this is that logical representation of a set of data. You don't have to have deep knowledge of the actual database schemas within Athena or various data sources. And as a business analyst, I could go in and select the rides data set and create a new analysis from this. And what we do here is, very easily start interacting with this. Under the covers, I don't need to know this as a business analyst, but under the covers, this is doing an Athena query now. And it's aggregating how many fares there were per year. And you'll notice this is a really big data set. This is close to 3 billion entries. I could go in here and, of course, modify this chart. So since this is a year, I might want to show the year like this, just show it, there's no commas within the year number. But this is a very big data set. This is close to 3 billion entries. What we could also do is we could start selecting columns such as timeline column. So I'm going to pick the pickup date time now. And within here, we could add filters. So within here, if we only care about 2016, we could go over here and select a particular year. And then we could say, I only care about 2016, looking at that over time. So what this is doing now, all under the covers, is it's issuing those Athena queries and very easily able to show the plotting of this. Since this is a time field, you have flexibility in how you want to aggregate this data. So let's go ahead and look at it per day. Now what this is doing is under the covers is doing the right aggregations against the query engine using Athena right now. And what we're able to see here is the total amount of fares per day over time here. Since this is 3 different data sets combined into one visualization here, or one data set, I could go ahead and split this timeline chart based on the type of data. So now what you're going to see is you're going to see it split out based on green taxi data, yellow taxi data, and for hire vehicle. And you see that in the timeline now. What's interesting is this is real data set. We wanted to start bringing in and analyzing it. New York City Transportation made it really easy for us because they already had their data on S3 for us. So we could start querying it very, very easily. But what we notice here is this giant drop on the number of taxi rides on a particular day, January 23rd, 2016. What's interesting is we didn't know anything about this data. We just started looking at it. We started visualizing it, and through the visual representation, it's very easy to see this drop. And if you Google this, it's quite interesting. There's actually a blizzard in New York City that day, and everyone was told to stay inside, and that caused a big drop in terms of the number of taxi rides. We could also do things like add additional visualizations very easily here. So I'm going to add a new visualization and do some resizing of the windows here. And in the second visualization, I'm going to plot the hour of the day. And up here at this top display, I'm going to change the units. So over here, we could switch the units again rather than per day. Let's look at it per hour. And what we're going to be looking at here is 2 charts. One is a timeline view, and the other is a bar chart. The bar chart is just looking at the hour of the day and the number of rides there are. And the timeline chart is over time, giving us the trending information. On the chart on the right here, what we'll notice as we scroll down is between midnight and 5 a.m. is when the least number of taxi rides there are. And that's expected, right? It's in the very wee morning hours. Not many people are riding taxis and for hire vehicles. We could easily see that trend when we're looking at this per hour. But what's interesting is if we scroll all the way to the left here, we see this really big spike around 2 a.m., 3 a.m., much greater than the peaks during normal days. And it's very easy to see this through this visualization. But when we hover over it, we see it's after New Year's Eve. So the ball drops, people are out celebrating New Year's Eve and New Year's Day, and they have to get home. And there's actually a very high surge of taxi rides at that time. So next, what we're going to show is what it took to start doing this in the serverless environment using Athena and Quicksight. So to do that, we're going to take a look at this data set again. So this is New York City data set. And if we look over here, these 3 different data sets are actually in completely different formats, or they're all CSVs, but they call different attributes different names. So let's start small. Let's just look at one month of data. So what I've done is I went ahead and loaded 1 month of data into one of my S3 buckets. So if we take a look at that, what we see is this file, or this object, I should say, is a little bit less than 2 gigs of data. So this is just 1 month of data. We were querying over 8 years of data, so we'll talk about how big that was in a moment. But looking at this 1 month of data, if we want to start analyzing this using SQL, I'm a data engineer, or a data scientist, or engineer who's very comfortable in SQL now. I'm switching my hat. Let's start analyzing this data using select statements and using Athena. So to do that, I could simply go over to Athena through the admin console. Athena also provides a JDBC endpoint to be able to connect to it. So you could connect through various means that know how to talk to JDBC. And what I could do here is I could go ahead and create a database or create a table through a wizard. And this isn't a table in a traditional database sense. This is really a schema on read definition of the data. So the data is being stored in the raw form on S3. In this case, it's a CSV. And what we're doing is we're actually defining a table representation of how to execute select statements against that raw data. We're not transforming the data. We're not loading it into a different proprietary format. We're keeping it in the raw form. But as Greg was mentioning, since this is Hive DDL based and Hive metadata store compliant, what we could do instead of using a wizard is we could also paste in a Hive query here. And what this query is doing is it's really defining the various fields within that CSV. So I could run this query. And what we'll notice is a new table showed up here. These are various databases. Databases are just logical groupings of tables that allows you to organize these various tables within those namespaces or groupings. Let's take a look at the data. So we could quickly select that little I button and see the first 10 rows of this data set. So what you'll notice is that returned very quickly, but it's just a limited 10 queries, not scanning all the data. But right away, we can start looking at the data. Let's start analyzing the data a little bit more complicated than that. We'll start with a simple select statement, but we're going to count the number of records. Remember, this is just 1 month of data. We're going to start querying 8 years of data in a moment. And in 1 month's data, you see a little bit over 10 million rows. So that's the number of rows, the number of taxi rides in that single CSV file. Since this is ANSI SQL, it's very easy to do more complicated queries. So let's do one now. And we're going to take the vendor. Various taxi types have various vendors. We're looking at yellow taxis, and we're going to count the number of rides each vendor has along with the average fare amounts. And what we see is vendor 1 and 2, close to the same amount of rides and close to the same amount of fare. If we take a look at the New York City taxi data, though, we see vendor 1 and vendor 2 are really IDs for a name. And what we could do here is we could transform the data. We could do an ETL. We could get it into a different form. But in select statements, we could also do a case statement here, since this is ANSI SQL at this point. So when we query this now, what you'll notice is within a couple seconds, less than 2 seconds here, you'll notice we did a little bit more complicated of a query. We renamed the different fields. We're aggregating, we're counting, we're taking the average total fare amounts, and getting this data back very, very quickly. So, what if we wanted to analyze all the data? So this is 1 month of data in CSV form, and you'll notice the data scanned here, since it's a CSV, the data scanned is actually the entire file, because it's not in a column-oriented storage. It's essentially scanning through the CSV, pulling out the right records, and running the aggregations as you're executing these. If I wanted to do this for the entire data set, for just yellow data, so this is not looking at the green or for Hive vehicle data yet, I have another table defined here. This is one that I already had defined, pointing to a separate S3 location that had all the yellow data. So if I run this query, we're going to notice that it's going to take a little bit longer than the previous query. And the reason why that is if we look at the amount of data this is scanning, you'll notice each of these files is quite large. So what's happening here is we've already looked at this data. We started analyzing it. We made a decision. We want to start analyzing the full amount of data. This is a really good time to really optimize the way you're storing the data in partitioning and column-oriented storage. And we're going to do that next. But let's go ahead and take a look at this query again. And you'll notice this query took quite a bit longer than the previous one. The previous one was less than 2 seconds. This took 25 seconds. Still very fast, very interactive, but we could do a lot better than this. This is stored in a CSV. You'll notice it scanned 207 gigs. This is just yellow taxi data. This isn't the green taxi data and for Hive vehicles. What we've done now, though, is, what we wanted to do is we want to optimize for queries. We wanted to still store it in open standard formats. So we're storing it as Parquet. Many technologies know how to talk Parquet or ORC or Avro or various technologies that are optimized storage formats. We're storing that in S3, but we're storing it in that optimal form. And what that looks like is if we take a look at the data that's already been transformed. So I've ran it through a transformation. The other thing that we've done here is we've actually taken all 3 data sets. We transformed it into a canonical form, meaning one syntax. So every all three of the data formats have been renamed, so the field for pickup date is the same field name to make our business analysts to be able to query the data very easily. So if we take a look at this format, though, you'll notice year, then month, and then type of cab or vehicle. So this is the formatted data here that is a very optimal way of querying the data. So if we go back to Athena now, and we take a look at this rides table, this is one that I already had in here. This is pointing to that location that you just saw as that partitioned data set. So let's start querying this data now. The first thing that we're going to do is we're actually going to do the same query that the Quicksight tool was doing as a business analyst. We're going to take the year, we're going to count the number of records and group by the year. And so what this is doing now is it's looking at each of the years worth of data. It's counting the number of records and returning the results. And that returned in a little bit under 10 seconds. But what you'll notice is the amount of data scanned, since it's stored as Parquet, there's a lot of optimization in terms of how the column metadata is stored. When we did this count query, it actually didn't have to scan over very much data at all. Very optimal storage for some of these queries. What we notice here is, if you add this up, it's a little bit less than 3 billion records. But what we notice is 2016 is a very popular year. So let's kind of focus on that year and figure out, per month, how many taxi rides there were based on the type of vehicle. So we could do this query now, and you're going to notice something. We do this query, and last time we had to, wait 9 seconds. This time it returned less than 5 seconds because it's doing that partition elimination. It's also not scanning over very much data, even though it's more complicated query. It's still scanned over a very minimal amount of the data. I could have optimized this further. Right now I have a smaller amount of Parquet files, more small files in my S3 location. If that's in larger blocks, this could be even faster. Let's do a more complicated query now within Athena. And let's do one that's doing things like 99th percentiles and taking the average cost per mile, the average distance, the average cost generally. And what we'll notice here now is this is a pretty complicated query. We're taking averages, we're doing group bys, we're singling out only yellow and green taxi rides. And again, you'll notice in less than 8 seconds now, all this data got returned back to me. It did all the percentile calculations, and it's very easy as somebody who knows how to do SQL to start diving into this data and start understanding the data set. So this is really powerful, very performant. You could optimize for both cost and performance by storing it partitioned and in column-oriented storage. But what I want to show next is, what if you had multiple data sets and you wanted to join those data sets together? And those data sets on S3 might be in different formats. You might have one in JSON. You might have another in a CSV. You might have another data set stored as Parquet. And if you want to join that data sets, those sets of data together, that's no problem within Athena. So within Athena, what I'm doing here next in this query, this data set is actually movie rating data. It's 10 million movie ratings, along with some additional metadata tables for movie details and user details. And this query is joining 3 different data sets together. They're actually in different formats. They're all delimited files, but they're delimited different ways. And what you'll notice is in less than a second, it was able to do this query over 10 million movie ratings and figure out the top 5 movie ratings per gender. So very easy to be able to start analyzing, fusing, understanding your data sets through the SQL interface. You could connect to this through things like JDBC as well. Not going to demo that right now, but multiple ways to be able to connect to Athena. Since this is one central data catalog, and having a central data catalog allows you to use various tools to interact with it, one of the other things that you could do is, if you already have an existing data warehouse, for example, you could point Redshift using Redshift Spectrum to that same data catalog. And what I'm going to show here now is I just connected to a Redshift cluster. And what I want to show is doing a couple of these queries. So the first thing you'll notice is I'm querying the external data catalog now. And these are all the same databases or those namespaces that have a collection of those tables that represent data on S3. And I could query that within Redshift using Redshift Spectrum. And for that same rides table, I could be querying that rides table, and I could join it with other data that I have in my data warehouse, all with that keeping it in the open data standards format on S3, but being able to extend and query into that from my Redshift clusters in my data warehouse. So next, that showed a little bit about how to query using Athena. What if we wanted to show the next steps of how we brought that into Quicksight? The steps are very easy to do that. So if we go back into the Quicksight, this might be your business analyst, but it might be also the data engineer. So your data engineer could create your data sets and then share it with various analysts within your organization. And what we could do here is we could go in here and say manage data. These are existing data sets that are already brought in. But what we could do here is we could create a new data set. And this is some of the tight integration that we have within the AWS services. So you could very easily auto-discover your Redshift cluster. You connect your RDS databases, but you could also connect your databases that you might have running elsewhere, for example, on EC2. What we're going to show here now is how to connect through Athena. So I could use Athena connection. I could create a new data set. And then within this dropdown, you'll notice this is the same data catalog, right? So this data catalog, this central data catalog is core to being able to have a very robust data platform. And we could select a particular database. We could bring in the rights table, for example. And what this allows me to do now is I could load this into Spice. So this is very, very powerful if you want to essentially have a cached for version of the data in Spice, very, very quick to query. You can set refreshes on that cache so that it stays refreshed at the interval based on your business requirements, or you could set it to query directly. The other thing that I want to show is as a business analyst, when I was going through Quicksight at the beginning, you saw hour of the day, but you'll notice the data itself actually doesn't have hour of the day. And the reason why that was, even though I was a business analyst and I had no idea that this was happening, is that was actually a calculated field. And to do that within the data prep phase, you could create a new field here and create additional calculated fields off of the base data. So what we did up front before sharing the data set is we actually said extract hour of the day out of the pickup date and call that hour. And then we said create. And as soon as you do that at the data set level, all the folks that may be using that data set will see that as if it's a field that they could start using and visualizing within their data. And then after that, you could go in and save and visualize this data, share it with others. And now we're back to that business analyst role or that data scientist role who wants a nice interface to be able to interact with rather than using SQL-based interaction. So those were the key aspects we wanted to run through demo-wise.